All right, so this is the second half of our notes for today. We actually had to jump around a little bit just to piece some things together. So this is questions 1 and 3 from your journal. All right, so questions 1 and 3 from your journal. So we're doing this in 2 parts, and I apologize for that. So we're going to locate a fourth point to create the designated quadrilateral. So we learned that a parallelogram has two sets of parallel sides, and we know that parallel sides have the same slope. Okay, so I'm going to look at this line segment right here, and I'm going to calculate the slope of that because I'm trying to find the missing point. So let's see, to go from this point to this point, I go down 1 and to the right 1, 2, 3, 4, 5, 6. So the slope of the red segment is down 1 to the right 6. I also need to calculate the slope of, whoops, I want to change the color on that. I also need to calculate the slope of this line segment. So let's see, I go up 1, 2, 3 over 1, 2, 3. So the slope of the purple segment is 3 over 3, which actually equals 1. So I know that from this point right here, I have to draw a line segment that has a slope of negative 1/6. Down 1 to the right 1, 2, 3, 4, 5, 6. When I plot that point here and connect these two line segments, I see that the red line and the black line have the same slope. But I also am turning this into a parallelogram, so I need to verify that the green line segment has the same slope as the purple. Up 1, 2, 3 over 1, 2, 3, and it does. So the ordered pair that I was missing is the ordered pair 1, 0. Now for a rectangle, we know that a rectangle has 4 right angles, which means that the sides are perpendicular, and it has 2 sets of congruent sides. Opposite sides are congruent. So I can actually just use the distance between these 2 points, 2, 3, 4, 5, 6. And I know that I need to model that. The point from the distance from here to here also needs to be 6. So 1, 2, 3, 4, 5, 6. So I'm missing this point right here. Then I just want to check and make sure that my vertical distances are the same. And you can actually tell that by looking. So the point that you're missing on this one is the ordered pair -4, -8. I also know that I have 4 right angles. How do we know that? How do we know that we have 4 right angles? Well, because we have 2 horizontal lines and 2 vertical lines. And we know that horizontal and vertical lines are perpendicular to each other. Okay, so that's example number 1. Example number 3. We have to prove that the vertices D, E, F, and G form a square. So much like example number 2, the first thing I want you to do is plot your points. So the ordered pair 1, 3. Oops, I just dropped my pen, sorry. So I have the ordered pair 1, 3. I have the ordered pair 7, -3. That's E. I have the ordered pair 1, -9. That's G. And I have the ordered pair -5, negative 3. Oh, this is actually G. Sorry. This one I just plotted over here was F. Sorry about that, guys and gals. So I'm going to plot my points, and I'm going to go ahead and connect my line segments. So we need to show that this is a square. So what do we need to do first? First, we're going to use the midpoint to show it's a parallelogram. By the diagonals bisecting each other. So what are my diagonals? Well, I have GE and DF. So the midpoint of GE, well, that's just my x coordinates of G and E, 7 added to negative 5 divided by 2, and negative 3 added to negative 3 divided by 2. So the midpoint of GE, well, 7 minus 5 is 2, so 2 over 2, and negative 3 is negative 6 over 2. I can reduce that to 1 comma negative 3. 1 comma negative 3. Well, let's find the midpoint of DF. So I'm going to add the x coordinates of D and F, 1 plus 1, and divide it by 2. And I'm going to add the y coordinates of D and F, 3 and negative 9 divided by 2. So 1 plus 1 is 2, so that's 2 over 2. 3 minus 9 is negative 6. That gives me negative 6 over 2. And again, both of these reduce to 1 comma negative 3. So what have I shown? Well, I've shown that D, E, F, G is a parallelogram. Okay, that's step number 1. Now I need to show that it's a rectangle. So second, I'm going to use the distance formula to show it's a rectangle because the diagonals are equal. The lengths of the diagonals are equal. So let's see, what are my diagonals? Well, my first diagonal is the distance from G to E. So I'm going to use the distance formula. All right, so I'm doing G to E. So negative 5 minus 7, the quantity squared, plus negative 3 minus a negative 3, which is plus the quantity squared. Okay, so negative 5 minus 7, well, that's negative 12. And negative 3 plus 3, that's 0. So negative 12, the quantity squared, well, that's just 144. And the square root of 144 is 12. Okay, so that's the distance from G to E. Now let me show the distance from D to F. Okay, D to F. Let's see. So D to F. 1 minus 1. Whoops. Those are my x coordinates. The quantity squared plus 3 minus a negative, which is plus 9, the quantity squared. Well, 1 minus 1 is 0. And 3 plus 9 is 12. So 12 squared is 144. And the square root of 144 is 12. So guess what? What have we shown? We've shown that D, E, F, G is a rectangle. Why? Well, because the diagonals are equal. We just showed that. So what's the third thing that we need to do? Well, third, we need to show that the diagonals are perpendicular with slope. That's going to make it a square. So I need to use the slope of the diagonals. So the slope of GE. Well, let's see. The slope of GE, -3 minus a negative, which is plus, all over -5 minus 7. So -3 plus 3, well, that's 0 over -12. Well, 0 divided by -12 is just 0. So the slope of GE is 0, which means that it's a horizontal line. I love that. Let's find the slope of DF. The slope of DF. Okay, well, -9 minus 3 over 1 minus 1. Well, -9 minus 3 is -12, and 1 minus 1 is 0. Anytime we divide by 0, that means that our slope is undefined. We don't divide by 0. And what kind of lines have undefined slope? A vertical line. So what do we know about vertical and horizontal lines? We know that they are perpendicular to each other. So I don't want to write the slope. I just want to write. So I know that GE is perpendicular to DF. So DEFG is a square. Alrighty.